Welcome back. Today we're going to be talking about dividing and power-to-power exponents. Our content objective is students will be able to simplify expressions with exponents that are positive and zero. Language objective is students will be able to explain in the words the process of simplifying exponent problems. Why am I learning this? Well, it's important for real-world problems like representing the size of something very small, such as the diameter of a white blood cell. First, we're going to go over some background knowledge. Remember, this here is called the exponential form. We would read this as 3 to the 4th power. Our base is the large number, and our exponent is the smaller number at the upper right-hand corner. The base tells us what we're repeating, and the exponent tells us how many times. Here is the expanded product, which can also be referred to as an extended product. They mean the same thing. And you're going to notice we might use those words interchangeably in this lesson. 81 would be the evaluated answers. You're simplifying it as much as you can. We even practice writing them as expanded products and then evaluating, again, which means we multiply them out. So this is from our previous lesson. So hopefully this looks familiar. We even talked about some vocabulary. Exponential form is using the base and the exponents. An expanded product is when you write it all out. And again, evaluated means you simplify it as much as you can. In this case, it multiplied to be 32. We talked about special exponent problems and how we would read it. In this case, we would read this as the opposite of 4 cubed. Okay, and this is how you would express it. This one would be read as the opposite of 6 squared, and this is how you would express it. So please remember that it's not the same as something written like this. Here, this is not the opposite of 4 squared. This is actually negative 4 squared. So it's important to understand the difference between the two. When there's parentheses, when there's parentheses around the negative number and the negative number alone, that base is negative. Without it, it is not a negative base. So here, just remember, in this case, this is the opposite of 5 squared, and this is negative 8 squared. So because this had parentheses around the base and just the base alone, it was negative 8 squared. So we're going to be asked to rewrite the following as an equivalent expression in simplest exponential form, and then to evaluate. So we're going to do both. So here we have 5 to the 6th over 5 to the 4th. First, the best tip that I can give you is to always write things out as an expanded product. By doing that, you will be able to see what you could do next. So in this case, what does 5 to the 6th look like? Well, 5 is going to be repeated 6 times, so I'm going to go ahead and write it like so. 5 repeated 6 times. Here. Well, again, I'm going to repeat the process. In this case, the base is 5, so the 5 is going to be repeated a total of 4 times, and that's going to look like that. Now, immediately, what my brain starts to think of is, hey, I'm going to cross-cancel it because I can reduce. So I will do that. Both these two can be reduced by a 5, so we're going to do that. And I'm going to do that until I can't anymore, which then leaves me with 5 squared. Here would be my exponential form, okay? And then we're not done. We're asked to evaluate, so I'm going to go ahead and do 5 squared. Means 5 times 5, obviously, which is 25, and that is my answer, evaluated. So notice, since they did ask us for exponential and evaluated, these are my two answers. And again, an expanded form is definitely going to help us figure out what we're going to do and what's going to happen. So definitely suggest you do that whenever you're stuck. The instructions are the same. It says to rewrite the following as equivalent expressions in simplest form and evaluate. So I'm going to go ahead and do a couple more with you, and then I'm going to have you pause the video and try some on your own in a moment. Here, this is 2 squared, so I'm going to go ahead and write 2 a total of 2 times. 2 squared, which is exactly the same. I'm going to go ahead and you can think of it as cross-canceling or cross-reducing. I like to call it cross-reducing because that's exactly what's happening. The numbers are getting reduced. So here we're going to reduce 2 and 2 by 2, which leaves us with 1. Again, I repeat the process. And now I'm left with 1 over 1, which is just 1. So here, was there really an exponential form? Well, you could think of it as that is 1 to the first power, and then evaluate it is just 1. So just keep that in mind. Oops, got ahead of myself. Now here, what is being raised to the 4th power? It is a -2. And how do I know it's a -2? Because the base is surrounded with parentheses and just the base alone. So I'm going to go ahead and repeat the base of -2 4 times. And then in this case, repeat the base of -2 3 times. Again, I can see that I can cross-reduce. So I'm going to cross-reduce by dividing both the numerator and denominator by -2 until I can't reduce anymore. In this case, I'm just left with a -2 over 1, which is just -2. So again, technically as exponential form, you could write it like that. We typically don't. Just leaving it as a -2 would suffice. Now, when we're evaluating it, is it necessary to put the parentheses? No. Okay, so please keep that in mind. Okay, now at this point, what I'd like you to do is go ahead and pause the video and try 3 and 4 on your own. Okay, so let's see how well we did. I know number 3 looks slightly different, but the process is exactly the same. 1/2 to the 4th power will look like this. 1/2 repeated 4 times. 1/2 squared will look like this. It's 1/2 repeated 2 times. I'm going to go ahead and cross-reduce as many 1/2s as I can from the numerator and denominator, which is going to leave me with 1/2 squared. Please remember from the previous lesson that whenever your base is a fraction or if it's a negative, it does require parentheses around the base alone. So that's why we need these parentheses. Without them, they would technically be incorrect. So now that is my exponential form. I'm going to evaluate it. So I'm going to multiply using this because it's still here. 1 times 1 is 1, and 2 times 2 is 4. So we have 1/4 as our evaluated answer. So for number 4, hopefully you wrote it as -8 over -8 repeated 3 times. I'm going to cross-reduce as many -8s as I can from the numerator and denominator. It only happened once, leaving me with 1 over -8 squared. So there's my exponential form, but taking it a step further to evaluate, I'm going to multiply it out. Of course, a 1 is going to be a 1, but here -8 times -8 will turn it into a positive 64. So there are your answers. So hopefully you got those right. If not, please take a second look at this video and check to see where things went wrong. Okay, once again, I would like you to pause the video and try number 5 and 6 on your own. Okay, so let's see how well we did. Hopefully you wrote it out as 3 repeated 2 times. Here, 3 repeated 3 times. You reduced, and you would be left with 1/3. So here, we're just going to go ahead and accept that this is the answer at exponential form and evaluate it as well. Number 6, here we're going to write -7 4 times in the numerator and 7 times in the denominator. You're going to cross-reduce as many -7s from the numerator and denominator as you can. Here I'm left with 1 over -7 cubed. Notice I did leave the parentheses around the base. It's important to do that because the base is negative. And then last but not least, we're going to evaluate. So multiplying a negative times a negative is going to be a positive, but times another negative is going to be a negative. And I know 7 times 7 times 7 is 343. So here we have 1 over -343. Okay, so now we're going to explore the exponent of 0. Let's see how we get that answer. Here we have 2 to the 4th. Here's how you would write it. 1 times 2 repeated 4 times, which is 16. Okay, well now if it's 2 to the 3rd, we're just going to use 1 less of it, 1 less 2. So here we're going to do 1 times 2 times 2 times 2, which leaves us with 8. Repeating the process, 2 squared is 1 times 2 times 2, which is 4. And 2 to the first power is 1 times 2, which is just 2. Okay, so using this pattern of 1 less 2 to get 2 to the 0, we'd be left with just 1. Now, how does this work and how can I confirm this? If you will notice, we went from 16 to 8, 8 to 4, 4 to 2, 2 to 1. What was happening every single time? Since we were losing a 2, essentially you were dividing off a 2. So notice 16 divided by 2 gives you 8. 8 divided by 2 gave you the 4. 4 divided by 2 gave you 2. So the only next reasonable thing would be, okay, to get to the next step, what would I have to do? 2 divided by 2 is 1. So that is why we know any number raised to the 0 power is 1. Okay? Positive exponents indicate repeated multiplication, and that's what you see here. A number raised to the 0 power is always going to equal 1. Any number raised to the 0 power is 1. So now what I'd like you to do is go ahead and pause the video and try a couple of these on your own, implementing the power of 0. Okay, so let's go ahead and practice and see our answers. For here, negative 4 raised to the 0 power. Remember, anything raised to 0 power is 1, so this is 1. What about B? 4 squared. Well, that means 4 times 4, so that's going to be 16. Here, C, be very careful. The correct way of reading this is the opposite of 8 to the 0 power. We know 8 to the 0 power is 1, but if we take the opposite of it, it will be negative 1. D, we have negative 2 squared, so we're going to go ahead and repeat a negative 2 2 times. That's going to leave us with a positive 4. E, we have 10 to the 0 power. Anything to the 0 power is 1. Here, for F, we have the opposite of 5 cubed. So first, we're going to do 5 cubed. 5 cubed is 215, but we still need to take the opposite, so then it becomes negative. Sorry, I said 215, I was incorrect. 5 cubed is 125. So to take the opposite of that, it would be negative 125. For G, here we have 3 times 4 minus 1 raised to the 0 power. First, you can just remember, hey, anything raised to the 0 power is 1. Or if you wanted to, you could have simplified this and said this is 12 minus 1 is 11. 11 to the 0 power is still 1. Now, H is a little tricky because you see a lot of negative signs, but the way you would read this is the opposite of negative 3 squared. Well, first, we can do it in our heads real quick. What is negative 3 squared? It means negative 3 times negative 3, which is 9. But we're not done. We're asked to take the opposite of it, so that's going to give us negative 9. But really quick, let me show you the visual. Again, we're going to do what's inside the parentheses. Negative 3 times negative 3 is 9. But we're still left with taking the opposite of that, and that's going to leave us with a negative 9. Okay, so now we're going to go ahead and look into power to power. Here we have 5 cubed squared. Well, again, whenever you're not sure of what to do, always go back to the basics of writing things out. In this case, what's technically being squared? I would say 5 cubed. So I'm going to go ahead and write 5 cubed 2 times. So here's my first set of 5 cubed, and here's my second set of 5 cubed. Now I'm going to express it in exponential form. Since 5 is being repeated 6 times, I'm going to go ahead and write that as 5 to the 6th power. Here is our extended product, also known as the expanded product, and here is our exponential form. Now, is there another way of looking at it? Yes, there is. Instead of repeating the 5 as an extended product, I simply could have left it as 5 cubed repeated twice, like so. And then from there, I can say, okay, there's going to be 3 5s here and 3 5s here, so total there should be 6. Now, I do want to warn you, some of you may do this incorrectly, so if you are unsure, you should expand this out and say this means 5 times 5 times 5, and this means 5 times 5 times 5. Please do not assume anything. Definitely write things out when you're unsure. Again, using the extended product or an expanded product definitely helps to get you to an exponential form. It makes it a good visual for you to see. At this point, I'm going to go ahead and review a couple more examples before I try and give you an opportunity for you to see what you can do. Here, what I like to do is focus on, okay, so what is being squared? 3 to the 5th is. So I'm going to go ahead and write 3 to the 5th 2 times. Now, let's face it, writing it sometimes is going to be overwhelming. So I can just pretend. If I wrote 5 here and I wrote 5 here, how many would I have altogether? I would have 10. So I'm going to write 3 to the 10th power. Now, if you feel it's definitely beneficial for you to write 3 5 times and then go from there, I think that's also a great option. But I just wanted to give you another option as well. Either or, you're still going to get 3 to the 10th. So now number 8. Here we have -2 cubed raised to the 2nd power. So here, what is being squared? I would say it is a -2 cubed. So here's written once, and here it is written twice. So again, let's imagine I wrote this 3 times, and then I had to write it another 3 times. How many would I have altogether? I would have 6. So I'm going to go ahead and write -2 to the 6th power. Okay, so let's try 2 more examples, and then it will be your turn. Here, for number 9, here we have 2 cubed squared. So what's being squared? 2 cubed. So I'm going to write 2 cubed, written once, written twice. And here we're going to pretend we wrote it 3 times for this one, 3 times for this one. So how many did we all have together? How many did we have all together? We would have 6. So this is going to be written as 2 to the 6th power. Now here we have 3 squared cubed. So what's being cubed? 3 squared. So I'm going to go ahead and write 3 squared 3 times. So here's 3 squared once, 3 squared twice, and 3 squared 3 times. Now, let's imagine we repeated it 2 times here, another 2 times here, and another 2 times here. We would have a total of how many? Hopefully your answer was, yet again, 6. So we're going to write 3 to the 6th power. But please, if this is something that you're struggling on, what I would highly suggest you do from here is write it out. Okay, so definitely do that if you need to, okay? Either or, you're going to get the same exact answer. Now at this point, please pause the video and try numbers 11, 12, 13, and 14 on your own. Okay, so now let's go ahead and check out our answers. So here for number 11, hopefully you repeated 5 to the 6th 2 times. It's going to leave you with 5 to the 12th. Number 12, here you're going to repeat 4 cubed 3 times, which should leave you with 4 to the 9th. Here we're going to repeat the opposite of 7 cubed 2 times, which would leave us with 7 to the 6th power. And yes, it would be even. If you're wondering why, well, let me show you. Since we are squaring the opposite of 7 cubed, like so. Okay, and real quick, let me just announce the fact that here the base isn't negative because otherwise the parentheses would end here. So just making that clear. You'll notice a negative times a negative is a positive, and that's why you should end up with a positive 7 to the 6th power. And number 14, what is raised to the 5th power? It is the opposite of 5 squared. Hopefully repeating that 5 times, you will see that you have -5 raised to the 10th power. So hopefully you got those right. If not, please go back to previous examples to see if that can help you. Okay, so that's going to conclude the lesson for today. Hopefully you reviewed how to work with positive exponents. As always, thank you so much for tuning in, and until next time, bye!